The last time the moon's shadow completely covered the city of Reykjavik was June 17th, 1433, 593 years ago. It happens again tomorrow, and it is not even the only thing on the schedule. 3 more events are due in the sky inside the same day, and almost nobody has planned for them. There is also something strange being said about tomorrow online, and we are going to check whether any of it holds up. By the end, you will know exactly what to look for, when, and where. Tomorrow, 4 separate astronomical events land inside a single 24-hour window, and along one narrow strip of the planet, every one of them is visible from the same patch of ground. Here's the schedule. Before sunrise, 6 planets stand above the horizon at the same time. Later in the day, the moon slides directly across the face of the sun and produces a total solar eclipse. At 5:37 in the evening, universal time, the moon reaches new phase. And once the sky goes dark, the Perseid meteor shower hits its annual peak with no moonlight interfering at all. The number that matters most in that sequence is 15.2 million. That is how many people live inside the strip of ground where the sun will be completely covered, roughly 1/5 of 1% of the human race. 980 million people will see some part of this eclipse, which is about 12% of everyone alive. Fewer than 1 in 500 will see the part that actually counts. The last time the moon's full shadow crossed mainland Europe was August 11th, 1999. Tomorrow is 27 years and 1 day later, so no, this is not an ordinary night with good marketing attached. But it is also not what a large share of the internet currently believes it is, and sorting the real event from the story riding on top of it is going to take the rest of this video. Start with the morning, because it comes first and almost nobody plans for it. Before sunrise tomorrow, 6 planets will sit above the horizon at the same time: Jupiter, Mercury, Mars, Uranus, Saturn, and Neptune. 2 of them are easy. Mars and Saturn are comfortable naked-eye targets, and if you have ever picked out a planet without help, you can pick out those. The other 4 are where people get frustrated. Jupiter is brilliantly bright, but sits very low, close enough to the horizon that a tree line or a neighbor's roof will hide it completely. Mercury is lower still, and it does not clear the horizon until shortly before the sun does. Uranus needs binoculars. Neptune needs a telescope. Mercury is the reason this has a deadline. Because Mercury rises so late, the window in which all 6 planets are above the horizon and the sky is still dark enough to see them is under 30 minutes in most cities on Earth. Miss it by 20 minutes, and the sky washes out from the bottom up. Here is where that window falls. In New York, sunrise is at 3 minutes past 6, and the useful stretch runs from roughly 5:18 to 5:34 in the morning. In Los Angeles, about 5:28 to 5:46. London, 4:54 to 5:03. Berlin, 4:56 to 5:04. Paris, 5:52 to 6:03. Toronto, 5:33 to 5:47. Mexico City, 5:35 to 5:53. Mid-northern latitudes get the best of it. New York, Madrid, Tokyo, where all 6 clear the horizon somewhere between 30 and 60 minutes ahead of local sunrise. In the southern hemisphere, the window closes harder. From São Paulo and Sydney, Mercury does not reach 5 degrees of altitude until twilight has already started, so Mercury and Jupiter will be a genuine fight. If you have never done this before, the trick to separating a planet from a star is that stars twinkle and planets mostly do not. A star is effectively a point of light, so the atmosphere shoves its image around and makes it flicker. A planet presents a small disk, and the flickering averages itself out. Look for the steady ones. Mars will read faintly orange, Saturn a pale yellow, and Jupiter will simply be the brightest thing in that part of the sky that is not the moon. And tomorrow morning, the moon will not be there to compete. Now the correction, because this is the single most oversold detail in the coverage. The planets are not going to form a line. They are not lining up in space. They are not stacking behind one another. And nothing gravitational happens tomorrow morning as a result of where they are. What they will do is appear spread along a wide arc across the sky, running from the eastern horizon toward the southwest, as seen from the northern hemisphere, and toward the northwest from the southern hemisphere. The reason is simple. Every planet in the solar system orbits in roughly the same flat plane, and from inside that plane, looking out, they always appear strung along the same curve across the sky. The curve is called the ecliptic, and it is there every single night of the year. So what is actually special about tomorrow morning? Only that 6 of them happen to be on the visible side of it at once, in a sky still dark enough to make them out. That is a viewing accident, not an alignment. It is worth setting an alarm for. It is not worth a single word of alarm. And if the weather ruins it, you have not lost anything permanent. The planets are worth watching the mornings before and after as well, with the layout shifting slightly day to day, which is the opposite of what happens next, because the next event on the schedule gives you 1 attempt and no second chance. The eclipse is the reason tomorrow ends up in history books. Here's the geometry. The moon's inner shadow, the part where the sun is completely blocked, will touch down over far Arctic Russia, cross eastern Greenland, clip the west coast of Iceland, race down the open North Atlantic, and come ashore over northern Spain, the Balearic Islands, and the northwestern corner of Portugal. That band of shadow is about 290 kilometers wide, or a little over 180 miles. The timing in universal time runs like this. The first place on Earth sees the partial phase begin at 3:34 in the afternoon. The first place to see the sun fully covered gets it at 4:58. The greatest eclipse, the moment the shadow's center comes closest to Earth's center, falls at 5:46 and 6 seconds in the evening. The last place to see totality loses it at 6:34, and the final partial phase anywhere on Earth ends at 7:57. That means the full shadow exists somewhere on this planet for 96 minutes. No location gets 96 minutes. The shadow is moving, and any single spot on the ground gets only the time it takes that shadow to sweep across it. It is worth pausing on why this is possible at all, because the explanation is stranger than the event. The sun is about 400 times wider than the moon, and it also happens to be about 400 times farther away. Those two numbers cancel, which makes the two disks almost exactly the same apparent size in our sky. There is no physical mechanism forcing that to be true. It is a coincidence of this particular moment in the solar system's history, and it is the only reason the moon can hide the sun's blinding surface while leaving the faint atmosphere around it exposed. The moon is also drifting away from Earth. Slowly, and in roughly 1.2 billion years, it will be too far away to cover the sun at all. Total eclipses will simply stop. In Spain, the whole thing happens in the late evening with the sun just a few degrees above the western horizon. Photographers are already calling it the most dramatic eclipse in decades because the black disk and the corona will be hanging low over the ground rather than sitting overhead. That same low sun is also the trap. A hill, a building, a line of trees, or one bank of low cloud can erase the entire event for someone standing perfectly positioned inside the path. Now the number that surprises people. The longest anyone on Earth can see the sun fully covered tomorrow is 2 minutes and 18 seconds. That maximum falls in open ocean off the west coast of Iceland, where nobody lives. For most people inside the path, totality runs under 2 minutes. Nowhere on land does it get past roughly 2.5. The local numbers are brutal in their specificity. In Reykjavik, the partial phase begins at 47 minutes past 4 in the afternoon. The sun is fully covered from 5:48 to 5:49, and the partial phase ends at 6:47. Totality there lasts about 1 minute. 1 minute for an event that has not happened over that city since June 17th, 1433. The next total eclipse over Reykjavik arrives in 2245. In Leon, Spain, the partial phase starts at 32 minutes past 7 in the evening, and totality runs from 28 minutes past 8 to 8:30. Zaragoza gets it from 8:29 to 8:30. Valencia gets a single minute from 8:32 to 8:33. In Serenal, on Mallorca, totality lasts 1 minute and 36 seconds, starting at 30 minutes and 56 seconds past 8 in the evening. So the entire scientific and emotional payload of this event, the corona, the darkness, the temperature drop, the animals going quiet, is delivered in about the length of a pop song, and in some places less. That compression is the whole reason the next section exists, because a lot of people are about to get 99% of an eclipse and think they got the eclipse. A partial eclipse is visible tomorrow across Europe, Northern Asia, North and West Africa, much of North America, the Arctic, and huge stretches of both the Atlantic and the Pacific. And the coverage numbers look extraordinary. Barcelona reaches 99%, Madrid reaches 99%, Algiers 96%, Lisbon 95%, Dublin 94%, Paris and Milan 92% each, London 91%, Casablanca 87%, Berlin and Vienna 85%, Oslo 83%, Stockholm 81%, Nuuk and St. Petersburg 79%. None of those cities will see the corona, not one. This is the part that does not behave the way intuition says it should. A partial eclipse is not a discounted version of a total one. There's no percentage that buys you a fraction of totality. The sun's visible surface is so overwhelmingly bright that even the last 1% of it, still uncovered, drowns out the faint outer atmosphere entirely. The corona appears the instant that surface is fully hidden, and not 1 second before. Barcelona and Madrid, two of Spain's largest cities, are going to make that discovery at scale tomorrow evening. The gap between those two experiences is not a matter of degree. Inside the path, the temperature drops. The horizon takes on a strange bronze color in every direction at once. Bright stars and planets come out in the middle of the day, birds stop calling, and a shadow you can see coming arrives at more than 1,000 miles an hour. Outside the path, at 99%, the light goes slightly flat and slightly odd, and that is all. People who have seen both describe them as different categories of event, not different amounts of the same one. In the United States, it is smaller again. Fairbanks gets 37%, Anchorage 28%, Bangor 24%, Portland, Maine 19%, Boston 16%, New York 9%, Philadelphia 7%, Washington 4%, Detroit 3%. In New York, the partial phase runs from 7 minutes past 1 in the afternoon to 2:38 Eastern Daylight Time, with maximum at 54 minutes past 1. Totality is not visible anywhere in the United States, and every one of those partial phases requires certified eclipse glasses for the entire time any part of the sun is uncovered. Sunglasses do nothing. That warning is not decoration. It applies to every city listed above. Now the item on the list that gets reported as the fourth coincidence, and is not a coincidence at all. The new moon arrives at 5:37 in the evening, Universal Time. Greatest eclipse arrives at 5:46. Those two moments are 9 minutes apart, and that is not luck. A solar eclipse can only happen at new moon because a solar eclipse is the new moon crossing the sun's disk. They are the same event described in two different vocabularies. Listing them separately is like listing thunder and lightning as two storms. But that raises the obvious follow-up. There is a new moon roughly every 29.5 days, so why is there not a solar eclipse every month? The answer is that the moon's orbit is tilted about 5 degrees relative to Earth's orbit around the sun. Most new moons pass above or below the sun from our point of view and cast their shadow into empty space. An eclipse needs the new moon to arrive near one of the 2 points, where those two orbital planes intersect. That is why eclipses come in seasons and travel in pairs, and this one has a partner already scheduled. A partial lunar eclipse follows on August 28th, and that same new moon is about to do something for the fourth event that no forecast could arrange. The Perseid meteor shower is active from the middle of July through the 24th of August, and it peaks tomorrow night into the early hours of the following morning. The Perseids are the debris trail of a comet called Swift-Tuttle. Every August, Earth plows through the stream of dust and grit that comet has shed across thousands of orbits. Those particles slam into the upper atmosphere at extreme speed and burn up far above the ground. And what you actually see is not the rock. It is the column of superheated air it leaves behind. Published peak rates run to about 150 meteors per hour as a zenithal hourly rate. Treat that number with care. It is an idealized figure that assumes a perfectly dark sky with the radiant point directly overhead. Under genuinely dark skies, the realistic expectation is up to roughly 100 per hour, and most people will count fewer than that. Here is what makes tomorrow night different. The peak lands on the new moon. There is no moonlight at all to wash out the faint end of the shower, and no moonlight to steal the fireballs. Those unusually bright meteors the Perseids are famous for, the ones that outshine the planets and leave a trail hanging in the sky for a second afterward. The next time this shower peaks under a new moon is 2045. From mid-northern latitudes, the radiant climbs high enough by around 10:30 in the evening, and the display improves through the night. The best window is after midnight and before dawn. The practical advice is shorter than people expect. Do not stare at the constellation Perseus, and do not use a telescope. A telescope narrows your view to the one patch of sky where nothing is happening. Lie back, take in as much sky as possible, and give your eyes a full 20 minutes to adjust without looking at a phone. The meteors will appear to travel outward from that one point in Perseus, which is just the direction Earth is moving through the debris stream, but they can flash anywhere overhead. There is one cruel detail in all of this. North of about 60 degrees latitude, which includes both Iceland and Greenland, the August sky never gets properly dark. The two best places on Earth to watch the eclipse are among the worst places on Earth to watch the meteors. Which brings us to the reason many of you first heard about tomorrow's date at all. For weeks, a claim has been circulating online that Earth will lose its gravity for 7 seconds on August 12th. The version that spreads fastest is very specific. It names a time, 2:33 in the afternoon, Universal Time. It cites a supposedly leaked document from November of 2024 describing a classified program. It attaches a budget of $89 billion, and it describes 7 seconds in which people and objects lift off the ground, followed by mass casualties when everything comes back down. Let us take it seriously enough to actually test it, because that is more useful than mocking it. Start with the time. The claim says 2:33 in the afternoon, Universal Time. Greatest eclipse is at 5:46 in the evening, Universal Time. Those are more than 3 hours apart. If the eclipse is supposed to be the trigger fires 3 hours before the event it is triggered by. The single most checkable number in the entire story does not match the sky. Now the mechanism, which is where it fully collapses. The gravity you feel is a function of the mass beneath your feet and your distance from its center. That is the entire equation. To reduce Earth's surface gravity to nothing for 7 seconds, you would have to remove essentially all of Earth's mass for 7 seconds and then put it back. A shadow cannot do that. A shadow is an absence of light. The moon's shadow crossing Spain removes no mass from anything, and the moon has been passing between Earth and the sun roughly every 29.5 days for 4.5 billion years without once switching gravity off. Then there's the document. There is no record of any program by that name. Independent fact-checkers went looking for the source paperwork and found none. NASA has stated directly that Earth will not lose gravity on August 12, 2026. It is worth asking why this particular story traveled as far as it did, because the answer is not that people are gullible. It is that the claim was built to sit next to a true one. There genuinely is a rare astronomical event tomorrow. It genuinely involves the moon coming between Earth and the sun. Both of those facts check out the moment anyone searches them, and once two details in a story verify, most people stop verifying. The fabricated part was then buried behind the part that survives inspection, which is the standard architecture of every one of these. Here is the part worth keeping. The tell was not the physics, but most people are not equipped to check the physics. The tell was the timestamp. A fabricated story has to invent numbers, and invented numbers do not survive being compared against a published ephemeris. When the next one of these arrives, and it will, check whether its central number lines up with a source that existed before the claim did. That is what tomorrow is not. Here is what it genuinely is, and it involves an aircraft doing something slightly absurd. NASA is flying a WB-57 high-altitude research jet along the eclipse path at 50,000 feet. Mounted in the nose cone is a set of 4 cameras, part of an instrument built by the scientifically calibrated in-flight imagery team at NASA's Langley Research Center in Virginia. Those cameras will record at least 20 images per second across several wavelengths of visible and infrared light. 2 reasons justify the flight. At 50,000 feet, the jet is above any cloud that could ruin the observation, and above enough of the atmosphere to reach infrared wavelengths that never make it to the ground, wavelengths in which the sun's outer atmosphere has been recorded only a handful of times in history. And by flying along the shadow's path at 460 miles per hour, the jet chases the eclipse and stretches its own view of the corona to nearly 3 minutes, against 2 minutes and 18 seconds for the single best-placed person standing on the ground. The target is a problem physicists have not solved. The sun's visible surface sits at a few thousand degrees. Its outer atmosphere, the corona, is heated to nearly 1 million. Energy is somehow moving from a cooler region into a hotter one, and the innermost part of the corona is the hardest place to observe because the sun's own glare swamps it. Spacecraft block that glare with a metal disk, and the disk hides the region scientists most want. Tomorrow, the moon does the job perfectly. From a distance, no instrument can imitate. The principal investigator on the camera experiment, Amir Kaspai of the Southwest Research Institute in Boulder, put the case for going back plainly. The sun is always changing, he said. Every eclipse is different, so the team could see things it has not seen before, and each eclipse teaches them how to observe the next one better. There's a second half to that campaign, and it is aimed down instead of up. The nationwide eclipse ballooning project, led out of Montana State University, is sending student teams to Iceland and Spain. In Iceland, 2 teams will launch a combined 80 balloons, starting 18 hours before the eclipse and continuing until 8 hours after it. Their target is the boundary layer, the lowest slice of the atmosphere, the part actually touching the ground, whose thickness rises and falls with surface temperature and humidity. Balloon flights during the eclipses of October 2023 and April 2024 found that this layer collapsed where skies were clear and did not collapse where skies were cloudy. Iceland in August is an awkward test because the days are long and the nights are short, so the usual day-night driver is weaker than it was on either of those earlier flights. In Spain, 3 more teams will launch 6 balloons carrying panoramic cameras to photograph the moon's shadow from above, along with instruments measuring ozone. Ozone needs sunlight to form, and similar experiments watched it drop during Totality in April of 2024. Whether that shows up again tomorrow is genuinely unknown, because this eclipse happens later in the day and in a different season. So here is what to watch for. If you are anywhere in the northern hemisphere, set an alarm for roughly 40 minutes before your local sunrise and find an open eastern horizon. That is the planets, and it costs you nothing but sleep. If you are in Europe, Northwest Africa, Eastern Canada, or the northern United States, get certified eclipse glasses today, because tomorrow's too late to order them. If you are inside the path across Iceland or Spain, your entire event depends on one variable you cannot control, and the historical clear sky odds are about 86% at Zaragoza and closer to 1 in 4 at Reykjavik. And wherever you are, go back outside after midnight. The meteors are the one part of tomorrow that does not care where you stand, does not require equipment, and will not repeat under a sky this dark until 2045. NASA begins streaming the eclipse at 15 minutes past 1 in the afternoon, Eastern Time, with feeds from Iceland and Spain. We will be tracking what the jet and the balloons actually bring back, because the images arrive within hours, and the answers take considerably longer.